These next few videos are on Bernoulli equations. So in the course so far, pretty much anything that's solved has been a linear ordinary differential equation. And there's lots of nonlinear ordinary differential equations as well. The reason that we only solve linear ones, though, is nonlinear ordinary differential equations are virtually impossible to solve. If you give a general nonlinear ordinary differential equation, nobody, dead or alive, knows how to solve it in general. So this equation here is called the Bernoulli equation because it can actually be solved. It's a somewhat rare ability for nonlinear differential equations. So this equation, nonlinear equations in general very difficult to solve. That's why this equation has been named, and it's named part of someone, Bernoulli, that I think first investigated them. So here we go. Here's how you're going to solve it, and it's pretty easy once you know how to do it, but very hard to come up with. So here we go. We have y prime plus p of x times y equals g of x times y to the nth power. And n can be any real number, but it kind of breaks down if n is equal to 0 or 1. The reason for that, if n equals 0, then we'd have y prime plus p of x times y equals g of x times y to the 0, but that's the same thing as just g of x, because y to the 0 is 1. So then this is a linear differential equation. We can solve it with integrating factor. That one isn't a super duper difficult nonlinear equation to solve. The other case, when n equals 1, is also a linear equation, because if you do that, you get y prime plus p of x times y equals g of x times y. And if you want, you can just rearrange that to y prime plus p of x minus g of x all times y equals 0. So these kind of two cases are kind of bad cases. Otherwise, it's a nonlinear equation for anything else. And the super duper secret trick is we're going to use u. This u substitution is equal to y to the 1 minus n power. And so let's just see what happens when we do that and what pops out. So if we do, let's take the derivative on both sides, then we end up with u prime equals, now we're taking the derivative of this chain rule essentially, so it's going to drop down a power of 1 minus n. Then we're going to have y, we're going to decrement this power, so we have 1 minus n minus 1. So 1 minus n minus 1, the 1 and the minus 1 cancel, so this is just 1 minus n, excuse me, I forgot, y prime, right chain rule, and that 1 minus n minus 1 becomes just y to the negative n. All right, so u prime is equal to 1 minus, sorry, I forgot my prime again, 1 minus n, y to the negative n, y prime. So now what happens when we plug this in, so we have a y prime term here, and so let's go ahead and solve for that. So then if we divide, we end up with u prime y to the n over 1 minus n is equal to y prime. Right, now we're going to go back to the original differential equation, y prime plus p of x times y equals g of x times y to the n. And so we're going to replace y prime with this u prime, y to the n over 1 minus n plus p of x. In order to get y, that's going to be, so here if I go back, I have u equals 1, y to the 1 minus n. So if I can rearrange that a little bit, so u is equal to y times y to the negative n. And so if I say u times y to the positive n, well, that's just equal to y. And so this y here becomes u y to the n, and that equals g of x times, y to the n. And now you'll notice all three of these terms just have y to the n inside them. We can essentially divide it out. So we end up with u prime over 1 minus n plus p of x times u equals g of x. And then if we don't want this fraction here, we can do u prime plus 1 minus n times p of x times u equals 1 minus n times g of x. And so if you want, if you have a Bernoulli equation, every time you're solving it, you can just jump the end to this formula and keep in mind that your, u is equal to y to the 1 minus n. You have to solve, substitute back y when you're done. But that's the idea. So, right, again, linear equations, we have some methods to solve them. We can't solve, even linear equations can be difficult to solve. And then for nonlinear equations, we can't really solve a lot of them. We being the entire world, every person that's ever lived and every person that is alive. And so this equation has a specific name to it because it can be solved. And that's why you're learning about it in your course.